So now let's talk about the domain name system, aka DNS for short. And DNS is actually a very big and decentralized system, but we're going to be looking at it in a pretty oversimplified way, but still we're going to go a little bit more in depth than you'll even be needing for system design interviews, but I think having this type of context can definitely be helpful for seeing the big picture. The main problem that we're trying to solve is we have a client. Let's say we want to access google.com. Well, we want to send a request to the google.com server. Let's say this is the IP address for that server. Well, are we going to type this into our browser? Does everybody need to know that this is the number of google.com? Like this is the IP address? It's sort of like having a phone book, or a more modern example would be in your phone, you have a list of contacts where you map each person, the name of every single person, to the phone number of that person. We want to do the same thing for domain names. We want to have a user-friendly name for a server. We want this to be pointing at this IP address, the same way we want somebody's name to be pointing to their phone number. So the very short explanation for this is that we have a domain name system where you want to go to google.com. Well, first find the IP address of google.com. Well, the DNS, the domain name system, will return that to our client, and then we have the IP address, so we know exactly where to send our request, and then we get a response from the server. At a high level, this is what's going on. This is what the vast majority of people know, because as software developers, you rarely need to go beyond this. And the same is pretty much true for system design interviews, but we'll be going a little bit more in depth. First, let's look at a quick demo. Let's say we go to google.com and press enter. Well, we're already at google.com, so it didn't do anything. But the point is that we get to this site. So what's going on is our computer is able to translate this domain to the IP address. And just to quickly illustrate this, I'm going to use a shell command called nslookup, and I'm going to pass in google.com, and the response that we're going to get is actually the IP address of google.com. So I'm going to take this here and copy and paste it. Now in our browser, I copy and pasted the IP address, and I'm going to press enter, and let's see what happens. Well, we got back to google.com. That's because the IP address belongs to Google. So whether we type in google.com or actually the IP address, we arrive at the website. So at the high level, that's really all there is to it. We have some type of decentralized system that is able to take a domain name and translate it into an IP address. And there are a lot of things that actually go on with this interaction with the domain name system. Of course, your internet service provider is a crucial component to it. None of this will function without, having the internet, and your internet service provider will interact with other servers. And there's another organization involved called ICANN. It stands for Internet Corporation for Assigned Names and Numbers. This is basically the owner of all domains in the entire world. When you type in a name like google.com, how do we decide that only one person owns google.com? Why can't I just steal that domain? Well, it goes through ICANN. It's a nonprofit organization, but ICANN doesn't actually sell the domain. Since it's nonprofit, there are accredited resellers of the domains, and these are called domain registrars. So basically, if you were to go online and buy a domain, you'd have to go through a registrar. One would be, Google Domains or Namecheap or GoDaddy, any of these. There are a lot of them, and they resell the domains on behalf of ICANN. Well, not really on behalf, but they're the only ones who are able to resell them. And so this is kind of how it works at a high level. So obviously your request would actually go through your internet service provider, and your internet service provider is what would interact with all these DNS components. So it would go through servers on ICANN, and these servers would somehow know that, okay, like the google.com domain, maybe it belongs to a particular registrar. The NeetCode.io domain, for example, it goes through the Google Domains registrar. So you can imagine that there would be kind of this chain of requests, and eventually ICANN would lead us to going to a Google Domains server, and that server is what holds the DNS record. So the DNS record basically stores information about resolving a DNS request. And there are many types of DNS records, but one is called an A record. A stands for address record. So this basically, I have one configured that says that NeetCode.io points at a certain certain IP address, and any request to neetcode.io should be forwarded to this IP address, and that IP address, let's say, belongs to my server, and then that would eventually be the IP address for this server, for example, and then the request would go back to the client. But you can see that this is already getting pretty complicated, and this is just a very high level overview, but I'm just trying to give you an idea of how all of this can work. There is an organization which owns all the domains technically, but there are resellers for those domains, and those resellers host servers which have the DNS records. So eventually a user request should land to one of these servers, which will actually do the translating for us. And then once that translation is complete, the client has that IP address. Now, usually the IP addresses aren't going to change for the servers very often. Usually they're static IP addresses, though static IPs are not required. There is something called dynamic DNS, which means that static IPs basically are not necessary, but that's kind of out of the scope of this course. But if IP addresses don't change super often, the client can actually cache these IP addresses. So if I type neetcode.io, I'll eventually get the IP address and it'll be cached on my computer. It'll be cached somewhere on the disk, I believe. If we want to talk to the neetcode.io servers, we don't have to go through this DNS query every single time. We don't have to know the IP address. We already have the IP address saved on our computer. This is kind of an example of caching. And so this kind of rounds out for us what the purpose of a server is. Typically, we do go through this DNS process to send requests to a server, but essentially summarizing the last few lessons, a server is essentially a computer with a public IP address, and typically that IP address has some kind of domain name associated with it. And this server's firewalls are configured to allow external traffic. Like for our own public router, suppose we had some router with a public IP address, we wouldn't necessarily want a public traffic to be reaching us. We wouldn't want external users to be able to send requests to our computer, so our firewall would block those. But for public servers, the firewalls are configured to allow requests to reach the server. And so what the server does is it receives requests and it fulfills those requests and sends the appropriate response, at least at a high level. And we'll start expanding upon what exactly a server can do. Now, I want to wrap up by looking at the components of a domain or a URL. We start with the protocol over here. Typically in a browser, you use mainly HTTP or HTTPS. We're going to go more in depth later on in the course, but you could use other protocols here. You could even access a file on your local file system on your computer in your browser, and you'll see that on Windows, for example, this will point to like your C drive. Now, this is the part of the domain itself. This isn't technically part of the domain. This last portion that we're all familiar with, COM, is called the top level domain, or TLD for short. You've probably seen other, obviously neetcode.io ends with a .io, and there are many others. There are country codes like JP would be for Japan. You can imagine that these top level domains also go through that organization that controls all of the domains, ICANN, and same with the root portion of the domain. So if you bought the google.com domain, this is what you would own. You'd own google.com, and this portion is called the domain name or the primary domain name, and this portion is called the subdomain. Subdomains are not necessarily required. Obviously, we could go to google.com, but also you can go to domains.google.com. This is basically what they use for Google Domains, the service where you can buy domains off of. Another example of the subdomain could be www, which I'm sure you've seen before. This doesn't really serve a technical purpose. It was mainly a convention that used to be used a lot. It's not so common these days, but some people still use it. So if you were to type www.google.com, you'd just be redirected to google.com. And the last portion is the actual path of the domain. This could, be anything. There could be, multiple things. It's followed by a slash, as you can see. You could also have some query params here and a lot of other things, but this is the path of the domain. This is not the domain itself. If you were to buy a domain from from some registrar like google.com, you would own the entire domain. You could also add as many subdomains as you wanted. You'd control this portion entirely. And if you owned this domain, you would basically put inside of a DNS record, you would, in an address record, most likely, you would want to say, okay, google.com, it points to some IP address which belongs to your own server. And so that's how this kind of phone book system, aka the domain name system, works. It's a very complicated service. We barely glossed over it, but luckily you don't really need to know the details for system design interviews. What we talked about here is more than enough.